Hello and welcome to our screencast temperature compensation of load cells without external compensation resistor. Our latest chip PS09 from the PICOSTRAIN series has an internal temperature measurement unit and therefore provides a very convenient temperature compensation. My name is Ralf Emberger and I will guide you through this screencast in which you will learn first of all about the theory of the PICOSTRAIN temperature compensation and how to apply this in practice. I will then show you how to do a full compensation in practice, and at last how to do an only offset compensation. Coming to the theory now, we first of all have a look at a classical Wheatstone bridge and how the temperature compensation is done there. You can see that for the gain compensation there are two R-span resistors used, and for the offset compensation there are two offset resistors R of 1 and R of 2 used. So a whole network of resistors is needed to compensate for temperature. Of course, also mechanical adjustment, for example for R-span 1 and R-span 2 is needed, and therefore also the load cell cannot be fully assembled before doing the temperature adjustment. Further approaches of conventional temperature compensation are shown in these pictures here. First of all, you can combine with the AD converter microprocessor, which has an external temperature sensor, for example an NTC sensor, and therefore obtain the temperature within the microprocessor and also do the compensation within the microprocessor. Another alternative is to have a second AD converter or an AD converter with two channels to sense the voltage over R-span and therefore detect temperature changes. However, both approaches need some additional hardware and or some more work to program in the microprocessor in order to do the temperature compensation. Coming from the conventional temperature compensation, we now have a look at the PICOSTRAIN temperature compensation, which is somehow a combination of the two conventional approaches by combining the separate temperature measurement but having it integrated in a temperature unit inside the chip. Since there's the resistor internally to sense the temperature, we sometimes refer to this approach by calling it integrated R-span. However, there's a whole temperature unit integrated into the chip, as you can see in the picture below. Generally, the PICOSTRAIN principle works on discharges from a capacitor. We call this the load over the strain gauge resistors by measuring the discharging times or discharging time intervals by means of a TDC. Having a closer look now at the PICOSTRAIN temperature compensation and how it works internally, we first can see in this picture here that there's a C load capacitance which is charged, indicated by the red arrow, and then discharged over the strain gauge resistor, indicated by the purple arrow. In this first step, the analog switches internally here are closed so that the sensing resistors, the temperature sensing resistors, here indicated R-span, are bypassed. They are internal temperature resistors and not really an R-span like we know it from outside, but just to show the similar functionality we labeled it R-span here, to have an internal or integrated R-span. Basically in the first step, as the analog switch is closed, we can draw a simple picture of how the discharging takes place. This is over the strain gauge resistors, but the R-spans are bypassed. So in a time interval diagram, this would mean to have here discharging and the charging with the red line in the first step. In a second step, the previously closed analog switches are now opened, so that the discharging can take place over the R-temp or R-span resistors here internally, so we have them in the discharging path. Drawn again in a simple manner, this means we have now the R-temp resistors in the discharging path together with the external strain gauge resistors. So you can see in the time interval diagram that we now get a discharging time which is longer than the previous one. So we can compare this discharging time and therefore make conclusions to the temperature. This is basically how the temperature compensation with PICOSTRAIN in PS09 internally works. In practice, independently whether PICOSTRAIN technology is used or not, there are principally two ways of temperature compensation which are applied. The first one is the full compensation, where gain and offset drift is compensated for with each and every load cell. The second method is to take only a sample out of a lot and make the full compensation there, and take the obtained values for correcting the gain and applying this for the rest of the lot, and doing only the offset compensation for each and every load cell separately. Of course, both ways are possible with the PICOSTRAIN temperature compensation. However, as the latter method is prevailing in practice, we are now focusing in our explanation on the second way of doing it. So let's have a closer look at possibility 2, where we can assume that we have a lot of, let's say, 5000 load cells to compensate for temperature. And out of this 5000, take for example some samples out, let's say 10 pieces, and determine the proper gain correction factor for these samples. This is done by the full compensation, and then afterwards, from the correction factors obtained of the 10 samples, you can calculate an average correction factor. So for example, load cell 1 would have a TK gain of 0.95, load cell 2 0.96, 3 0.94, and so on. So at the end you sum them up and calculate the average, which would be here in this example 0.95. So this is your gain correction factor applicable for the whole lot. That means also for the rest of the lot, here 4990 cells in this example. You can then use the average TK gain setting for the whole lot. That means using the same gain correction factor for all the load cells. In PICOSTRAIN we can do this very comfortably, since the TK gain is only a factor to write into a register to make the gain correction active. So we call this gain correction over the whole lot. It assumes load cells with similar properties and temperature behavior. And we also recommend to do a verification of proper gain drift behavior with some further samples out of the lot. Since the offset drift of each load cell differs, there's the need to compensate for it individually, done by only offset compensation. So to sum up, the only offset compensation method individually compensates for the offset of each load cell. Meanwhile, the gain drift is compensated for by adopting the TK gain values of only a sample and apply this to the rest of the lot. So we then now come to the practical part of the screencast, where I first will show you how to prepare the hard and software for doing the measurements. After having installed the driver and software on the computer, we then connect the sensor, the load cell, in this case a digital load cell, to an adapter PCB, where it puts to DLC, and plug in the whole adapter to the PicoBrook version 2.0 programmer. And that way we're good for starting the software now. Once the software is started, a message is coming up that the firmware is missing. Then a pop-up window will come up to select the firmware. Once this is selected, everything should work fine. We switch then here to I2C, since the digital load cell which is connected is operated by I2C, and then make a quick verification of the communication by clicking Power Reset, Download Configuration and Init Reset, and finally Verify Interface. Here the pop-up should appear OK, and then we know that the communication is established. From here we now go to the temperature compensation sheet and select there the configuration which is given here by OML 6000 or 3000 configuration to make this configuration active. We switch then to full compensation, since we want to do the full compensation here first. Having selected that, you can optionally go to the measurement sheet to adjust the sensitivity of the load cell there. If you know that this is normally around 2 millivolts per volt, which you can write into this field and then start a measurement just for test purposes. And we see here now that the measurement is running, since the measurement value is changing here. Another thing which you may want to check is if the internal rspan is activated. So on the ALU page you can confirm this by checking this internal rspan checkbox, and if this is checked, everything is alright. Going back to the temperature compensation sheet, we can then eventually start with the temperature compensation. Having everything prepared, we now come to the full compensation, which is the compensation of both the gain and the offset drift. For this purpose, please put the electronics and the load cell inside a temperature drift chamber and then set first the lower temperature, for example 10 degrees Celsius, and wait a settling time of at least 1.5 hours. This is to make sure that everything inside a temperature drift chamber has the same temperature. Once the settling time of 1.5 hours has passed, we can then start a measurement by first writing in here the proper temperature to this field. It should be the real temperature indicated by a temperature drift chamber or the sensor of it, not a nominal temperature. And then by clicking the button Start Measurement, the first measurements are performed. That means the first 4 lines of the blue fields are automatically filled. And then you will be asked to apply load to the load cell, where we recommend to put on at least half maximum load. However, this can be adjusted by this threshold field here. And once the message is coming up, like now, then you put on the load and the last measurement will be taken. Once the last measurement is taken, there's another pop-up message confirming that it was performed, and that's it for the lower temperature measurement. Having the measurements performed at a lower temperature, you can then set the higher temperature in the temperature drift chamber, for example to 40 degrees Celsius, and wait again the settling time of at least 1.5 hours. After waiting the settling time for the higher temperature, we fill again in this field here the temperature indicated by the temperature drift chamber or temperature sensor, and start then the measurement by clicking the button Start Measurement. The measurements are then taken automatically and filled in the first 4 lines as it was in the lower temperature. We then get the indication to apply load to the scale, and we will do that to make the final gain compensation measurement. Once this is done, a pop-up window will come up to indicate that the procedure was terminated successfully. We then get finally in the field here below the final TK gain and TK offset values. So this is basically what is needed for obtaining the TK gain and TK offset values. You now can additionally store them to the EEPROM by pressing this button and then say overriding the cells, so the proper factors will directly be stored in the PS09 itself. If the full compensation was applied to obtain the TK gain values to do later an only offset compensation, like explained formally in the theory, then you also need to write down 2 more values. This is the TK gain value itself up here in this field, and also the TK ref value. You should just write them down so you can later calculate an average TK gain and average TK ref, and I will show you in the next section of only offset compensation how to use them then. You just learned now how to do the full compensation of load cells with the PICOSTRAIN method practically. Of course you can apply this full compensation to each and every load cell individually, but if you recall the theory formally explained, then you know that you can also take a sample out of a load cell lot, make the gain compensation the way I proposed it here, and then take an average TK gain to make the rest of the load cell compensation by only offset compensation. So this is the way we want to do it now, taking this average TK gain value and then doing the offset compensation practically. After selecting the DLC config, we go up to the field reference values, where we first of all give in the TK gain and TK ref. You may remember that I ask you formally to write them down, and what you do is first calculating an average TK gain and TK ref out of the samples you have taken. Let me show you this on a separate slide. You may remember that at the end of the full compensation procedure, I asked you to write down two values in the reference values field, which was TK gain and TK ref. So doing this for the samples of a load cell lot, we can obtain, for example, 10 values for TK gain and also for TK ref. So having those in a table written down, you can then calculate the average TK gain and the average TK ref. And these two values are needed then to be filled in the new reference value field in the software here. So I'm filling in the corresponding values into the fields now before starting the measurement of only offset compensation. In only offset compensation, we do like in the full compensation set a lower temperature, for example 10 degrees Celsius, and write this into the field here. Then we start the measurement and the necessary measurements are done automatically, like shown here. Unlike the full compensation, you don't need to charge the scale with weight to do the gain compensation, since this is already given by the TK gain and TK ref values. So that's it for the lower temperature measurement. You now set the higher temperature, for example 40 degrees Celsius, and wait again the settling time of at least 1.5 hours before doing the measurements at a higher temperature. Once the settling time has passed, we then write the higher temperature to this field here, for example 40 degrees or 40.3 degrees indicated by the temperature drift chamber, and start then the measurement. These are taken again automatically by the software, and once the 4 measurement lines are filled with values, we then get the new TK gain, TK offset values calculated. So these are the final results, and you can of course store them into the eSquarePrompt by clicking this button again. So overall, this is all that is needed for the procedure of an only offset compensation. So that's it from my side, explaining the temperature compensation with an internal temperature measurement unit of PS09 to you. Thank you for watching, and please keep in mind that we have another screencast about temperature compensation, which is explaining the method for compensating with an external R span, which can be done with PS09 and PS081. So you can download this screencast along with a lot of other information in our download section, which you see the link here given, and some general information is also available in the products PICOSTRAIN section. So please have a look there, and thank you for watching.